5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
It's been 57 years since Apollo 11 rocketed into space, carrying the first humans to the surface of the moon.
Tranquility Base here. The Eagle has landed.
A mission that defined an era, an achievement that for a moment united and inspired a nation.
It's one small step for man, one giant leap for mankind.
When the Apollo missions ended, we didn't stop exploring. We built space stations. We launched telescopes. We learned how to live and work in orbit. But we stayed close. For more than half a century, no human has traveled beyond low Earth orbit. No one has ventured back into deep space until now. This week, NASA launches Artemis II, a mission that will send 4 astronauts farther from Earth than any human has traveled since the Apollo era, around the moon and back again. Not to revisit the past, but to begin something new. Because Artemis II isn't just a return. It's a stepping stone into deep space, testing the systems, the technology, and the limits of human exploration. I'm meteorologist Emily Gracie, and you're listening to Off the Radar, a production of the National Weather Desk. On the show, we dig deep into topics about weather, climate, the ocean, space, and much more. Our goal is to help you better understand the weather and to love it as much as we do. Welcome to Off the Radar. I'm your host, Emily Gracie. Today's episode is all about Artemis II, but really it's about something bigger than a single launch. It's about where we've been and where we're going. Because to understand why Artemis II matters, you have to go back to the beginning of the space age. In the 1960s, the Apollo program did something extraordinary. In less than a decade, humanity went from its first tentative steps into orbit to walking on another world. The moon became a proving ground, a symbol, and a stepping stone. After Apollo 17 in 1972, humans never went back into deep space. Instead, we built space stations, developed the space shuttle, and focused on operating in Earth's orbit. Important work, no doubt, but always close to home. For more than 50 years, the moon has been just out of reach. Artemis is NASA's answer to that gap. This new program isn't about flags and footprints. It's about building and sustaining a presence on the moon, establishing infrastructure in lunar orbit, landing near the moon's south pole where water ice may exist, and using everything we learn as a pathway to Mars. And Artemis II is the critical next step. It follows Artemis I, the uncrewed test flight that proved the Orion spacecraft and Space Launch System could make the journey. Now Artemis II will put humans on board for the first time, sending them on a 10-day mission around the moon and back. Think of it as a modern-day Apollo 8, a test of systems, yes, but also a test of what it means for humans to operate in deep space again. The crew itself reflects a new era of exploration. The mission will include the first woman and the first person of color to travel to the moon, and the first non-American astronaut to go that far from Earth. So Artemis II is both a return and a reset, a bridge between the legacy of Apollo and a future where humans don't just visit the moon, but they live and work there. And to help us understand that future and the science behind it, we're joined today by Dr. Barbara Cohen. She's a planetary scientist at NASA's Goddard Space Flight Center, whose work has focused on lunar samples, meteorites, and the history of impacts across the solar system. Her research helps answer some of the biggest questions about how the moon formed, how it evolved, and what it can teach us about Earth and beyond. In other words, she studies the moon not just as a destination, but as a record of our cosmic past. So in this conversation, we're going to talk about Artemis II, what makes this mission different, what scientists are hoping to learn, and why going back to the moon matters right now. Because it isn't just a return, it's the start of what comes next. Dr. Barbara Cohen, I'm so excited to talk to you today. This is a very exciting time for our country, and I want to hear all about Artemis II. Tell me, first of all, what your role is with NASA.
Well, hi, Emily. It's a pleasure to be here today. I am one of the Artemis project scientists. That means that for the science part of what we want to accomplish on each Artemis mission, we have a project scientist who kind of coordinates all those efforts and make sure that we can do the most science that we can with the resources that we're given on that mission. Of course, these are exciting missions and they include not just science, but a lot of other things that we're doing, especially these first few missions. They're really test missions. So they'll be testing out hardware, they'll be testing out operations. And so there's a lot that we're asking our crew to do. So it's not all science all the time as much as I would like it to be. So our job is really to, in the time that we have with the resources that we have and the mass and the things that we can bring, to maximize the science that we can get from the missions.
Gotcha. Okay, so this is Artemis II. Can you explain to me what happened with Artemis I? This is the first one with a crew, correct?
Correct. So Artemis I really was a test flight of the rocket, which is called the Space Launch System, or SLS, plus the crew capsule on top, which is called the Orion crew capsule. So Artemis I mated those together and pushed Orion out in a path that went around the moon and came home, tested the Orion's ability to withstand the rigors of space. It had some crash test dummies inside. It had a lot of instrumentation inside so that we could understand what was going on inside the cabin. And then it came back to Earth, came screaming back through the atmosphere, landed in the ocean, was recovered. And we looked at what happened to the Orion itself. So it tested the performance of the SLS and its ability to push the Orion out to the moon. And tested Orion's ability to withstand deep space and come home safely.
Okay, and so Artemis II, is it going to do pretty much the same thing, but with people?
Not exactly the same thing. So we already know the performance of the SLS, so we don't have to test that again. Now we're just doing it again. Now the Orion crew capsule also has life support systems and crew. So the technical configuration is a little bit different. And some of the things that we learned about the way that the Orion behaved in space on Artemis I, we've rejiggered the mission a little bit to implement on Artemis II. So we're not doing the exact same thing. We learned from our test flight and we're implementing those new things to help make crew more productive, more safe, to get better performance. So what the crew will be doing on Artemis II is the Space Launch System will again launch the Orion. It will go into an Earth orbit this time for 24 hours at a time. In those 24 hours, the crew will be testing out the Orion systems, the life support systems, and the ability for the Orion to maneuver. So one of the things that we want to be able to do with the Orion is to dock with other things like the human landing system that will get us to the moon. So they're just going to test the ability for Orion to maneuver by doing what's called proximity operations with other hardware in space. So they'll turn around, they'll do some maneuvering, they'll make sure things like the toilet works, which is going to be really important, that they can breathe okay, that they can move around, that everything's going to be really good for them for their next 9 days. So after a day of doing that, if everything is good, and we assume it will be, we'll do what's called translunar injection. So the upper stage will burn. It'll take them out past Earth orbit. It'll take them on a trajectory that will loop around the moon and fall back to Earth on its own. So they're not going to lunar orbit, although they will pass close to the moon. They'll see places on the moon that actually crew has never seen, so human eyes have not seen, because they will be farther away from the moon than the Apollo missions. When the Apollo missions, they were very close to the moon, so you couldn't see the whole moon disk. You could only see really the strip that was underneath you. So it's just a little quirk that the Artemis II astronauts will be farther away, but as a consequence, they'll see areas of the moon that human eyes have never seen. So that's a pretty nifty first. They are still captured by the Earth, so they'll push themselves away from the Earth, but then the Earth will recapture them and they'll fall back to the Earth on their own. And then they will go through the atmosphere, of course, and splash down in the Pacific Ocean where they'll be recovered.
When's the last time that humans kind of got beyond this International Space Station level of space?
1972.
Wow.
Yes.
Amazing.
I would date myself by saying I was born in 1971. So even though I was alive during Apollo, it's not something that is in my memory. It's not something that is in my career for sure. So this is definitely our generations and then the generations after me. It's our chance to really have a human spaceflight program that goes beyond low Earth orbit. Now, like you said, low Earth orbit has been where we've been. We've had 25 continuously inhabited years of the space station. So for the last 25 years, anyone who's 25 or younger, there has been a human in space the whole time, continuously inhabited. That has given us so much information and knowledge about how humans work in microgravity, how we live, how we keep humans alive, a lot of the mechanisms that we need, a lot of the way that the machines need to work, how much maintenance you need, how we can keep things going. So that has been absolutely invaluable experience. And now it's time to take all that experience and learn to live and work on another planet. We'd like to go to Mars, of course. I think a lot of people would like to go to Mars, but it's pretty far away. So we're going to learn to live and work on the moon, like a little station on the moon, like McMurdo Station or something like that, where we're going to go repeatedly. We're going to build up that experience and that knowledge. Then we're going to take that experience and knowledge, like we took it from space station to the moon, we're going to take it from the moon to Mars.
How many Artemis missions are there? Is it like open-ended?
It's open-ended. What we're trying to do is to establish that permanent presence and establish that base and collect that knowledge and that experience. So right now, we don't have an end date on that for when we'll have enough experience and when we'll have enough knowledge and when we'll have enough national capacity to be able to go to Mars. So right now, we're focused on getting these missions going and starting to build up that lunar base and starting to build up that knowledge and capacity.
Why do you think it's taken this long?
Well, it's not like we've been sitting around doing nothing, either within NASA or honestly, as a nation, right? I mean, you have all of the world's knowledge at your fingertips, right? That's something that we didn't have in 1972. It's literally, you can talk to someone in France, while you're walking down the street. The internet, right? That's an amazing capability. GPS satellites. Right? I don't know if you remember ever using a paper map. You might not be old enough, but paper maps.
Oh, I'm
right?
old enough, yeah.
You have to look up where you're going and then follow a map in your car while you're driving or have someone help you, right? Like GPS is an amazing capability. Our medical technology has come an amazing way since 1972. So societies have a lot to invest in for the benefit of their people. Space is one of those things that we do alongside a whole host of other things that we do to help our society gain and prosper. So in space, of course, we've been doing the International Space Station. That was our biggest endeavor over the last several years, and it's been incredibly successful. So taking those steps to go further is what we've been doing, and now we're ready to go further.
Awesome. All right, so tell me about the crew.
The Artemis II crew has been training for several years for this opportunity. They have to be specialists in a whole bunch of different places. They have to be able to pilot the craft. They have to be able to take care of all the machines and instruments that are keeping them alive. They have to be able to do these proximity operations. They have to be able to take care of each other and take care of themselves and keep themselves healthy and well. And then we want them to do the science on top of it. So they have biological and physical sciences. They have human research science. How are their bodies behaving? Then we have this lunar science we're asking them to do, which is look at the moon and describe these areas that no one's ever seen before. So I can tell you from my vantage point in the lunar science team, we've been working with crew very hard to get them excited about seeing the moon itself and trying to use words to describe the moon. That's what we're training them to do. It's not so much see the moon itself. We have lots of images of the moon. We have lots of spacecraft that are there that have been taking pictures in lots of different wavelengths and lots of different instruments. But the human eye and the human brain are the most sophisticated instrument that we have. We have a huge database in our brain. And the way our eyes work is not like cameras. Anytime you know from like criminal trials or when you're just recounting the party that you went to last night with your friend, you know, what you saw and what your friend saw or what someone else on the street saw is influenced by what your brain interpreted. We are not just spitting back video that we captured. So the way the human eye and brain works is what we're going to be using when we land on the moon and as we start to build up our lunar base. So we really want to know how that functions in terms of what we want them to do and how we're going to train them, and to be able to use those and harness those capabilities to our advantage to do all the science.
Wow, interesting. It's like another level of training I just didn't even think about. Gosh, they're going through so much. All right, well, you mentioned cameras, but I do want to know, like, are we going to get to witness this? I know there was TV coverage during the Apollo mission. So what I can only imagine it's like stepped up 1,000 notches for this.
Well, Artemis II, I can tell you that there's something like 25 cameras all around Artemis II. So there's cameras on the inside, there's cameras on the outside. We're having them use cameras to take pictures of the moon. NASA will have at NASA TV Plus, which you can also stream on, I think, Netflix and Paramount, I think, and you can also get it online anywhere that you just have a browser. We'll have 2 channels for the whole entirety of the Artemis II mission. One will be just switching camera views back and forth, and one will have commentary about what the crew is doing or things that are happening. So there'll be live coverage all throughout the mission, tons and tons of cameras. National Geographic has some cameras on there too, and I expect that they're going to do some amazing things with that footage when it comes back.
Anytime you're going to space, I know that there can be some dangers. And I mean, especially lately, like I feel like the public is so aware of solar activity and solar storms. How is that monitored? And is that a concern in this mission?
The way we monitor that information comes from a host of satellites that NASA and other countries have in space. So we do have things actively monitoring the sun, actively monitoring the radiation environment that we're all bathed in, the solar wind, all of those things, because you're right, it affects not just us, but our satellites in orbit and lots of other things that we have that we rely on every day. So there is an active space weather monitoring every day. Actually, there's a space weather forecast that comes out every day by NASA and NOAA and other government agencies who are monitoring these kinds of things. So that will continue all through the Artemis mission as well. They also have measures for if there's an unexpected coronal flare or something that's going to affect them negatively. They do have procedures for how to protect themselves from a very temporary increase in solar activity. But other than that, there are measures in place on Orion and on their suits and everything to protect them for the 10 days that they are out going past the moon and coming back in orbit around the Earth. But you're right, that does come with an increased radiation dose. Of course, anytime that you fly in an airplane or anytime that you go visit Denver, Colorado, or anytime that you get an X-ray, of course, you're increasing your dose as well. So those are things that the NASA surgeons monitor very carefully. Our medical professionals monitor those total dosages very carefully.
Cool. Okay. And what about weather on Earth? How is that monitored during I saw that the date is flexible, like no sooner than April 1st. So
Yes.
Is that because of weather? Is that because anything could go wrong? There could be a hiccup and things change?
Yeah, both those things. So weather certainly is a concern. We can't launch these rockets in any possible kind of weather. There are weather constraints. They're pretty lenient for a rocket of this size. So, we don't have any special concerns about snow falling in Florida this time of year or hurricanes coming this time of year, but there are weather constraints, clouds, lightning, storms, things can happen, wind. And then there weather constraints on the return as well. So we want to make sure that when they return in the Pacific Ocean, that there's nothing untoward happening in the Pacific Ocean. So both of those things go into saying, yes, let the rocket lift off now. That's a 10-day forecast, but that is absolutely a concern. But also, yeah, sure, these are test flights. We had Artemis I that flew. This is the second flight. So while we're confident in the performance of the SLS, actually lighting that rocket is a long process that depends on a lot of things going right. So we've had 2 wet dress rehearsals for Artemis II in which we nailed down, yep, here are the processes and procedures. These are how it's going to hand off. Here's how it's going to go. So we're very confident in that process. But yes, it's a big, complex machine. And so, yes, we monitor that process at any point. And if we need to stop and we need to take a breath and step back, we have multiple launch opportunities.
Gotcha. The return, coming back to the Pacific Ocean, because it is 10 days and it's hard to forecast 10 days, is it like a pinpointed location where it lands, or is that flexible? Can you be like, well, there's a hurricane here, so we're going to actually drop down over here?
No, it's kind of set by the trajectory. It's set by physics. So once they do their translunar injection, it sets them on a path that you can pinpoint where it's going to come back. That's physics and gravity for you. So we know exactly where they're coming back. I don't know what the uncertainty is, kilometers, something like that. But it's certainly not like you can divert them hundreds of kilometers someplace else.
Is it public information? Do people like take boats out there and sit and wait?
Oh, it's pretty far away, actually. It's much farther. There are people who go for launch at Kennedy Space Center who sit off the coast there, and there's a boat exclusion zone. But yeah, in the Pacific, it's pretty far away. It would be pretty difficult for a tourist to take a boat there. I'm pretty sure they do give those coordinates for shipping lanes, but it's pretty far from a shipping lane as well.
Oh, wow. Interesting. Okay. I want to talk about you and your background and your role in this. I saw you have a geology background. So does that mean that you're going to be playing with some moon rocks eventually?
Oh, man, I really hope so. Yeah, you see my rocks in the background. Yes, I am a sample scientist. I study samples from different planets, not just the moon, but also Mars and asteroids. And I try to understand when those rocks formed and what they tell you about the conditions under which they formed. So yes, I would love to study some more moon rocks. That would be amazing. We hope to get them from the south pole of the moon, which is a place that humans have never been and we don't have samples directly from. There are lunar meteorites that come to us from random places on the moon, but we don't have one that's tagged that says, I came from the south pole. So having that context, having a crew member pick it up and say this came from here is really important to us in sample science. So we'd like to know more about the kinds of processes that happen at the poles and the kinds of things that get delivered to polar regions and how long that took and what that told us about the ancient solar system that's recorded on the moon. So, oh yes, I would certainly love to get my hands on those samples.
Very cool. Do you have any information about that asteroid over Ohio a couple weeks ago?
Oh my gosh. It's interesting that it's not just that one. There was one over Houston.
Yeah.
And there was another one just very recently. And it feels like, wow, it's really raining meteorites. I have a friend who does the analysis for rocks that come in from space. And it's actually not an unusual uptick in terms of the total number. Things come to us literally every day, twice a day, 3 times a day. Something is entering the Earth's atmosphere somewhere. But of course, 3/4 of the Earth is water. There's no one there to see it when it comes in. And then not all of our land is populated. So if it, lands, comes in over an unpopulated area, remote Russia or something like that, no one will see it either. And so it feels unusual to us when it comes into a populated area and so many people can hear it and so many people can report about it. So these happen all the time and none of them were dangerous. Fortunately, it's just a good opportunity to maybe go pick up some meteorites.
Yeah. Well, we all have cameras, so we can all record it. So it seems like a big deal.
That's exactly right. That's exactly right.
I did an episode a while back on space junk. Is there any concern about, as we move towards the moon and eventually Mars, is that a concern when it comes to astronaut safety?
Well, right now it's not. They go through that area of Earth orbit fairly quickly, and we make sure that how they're doing it is fairly robust. So it's not a particular concern for the moon and Mars right now. I guess you can kind of imagine in your head what happens if we build up a GPS capability around the moon or around Mars, and sometimes our orbiters fail and just collect in space there. But that is so far in the future. Right now, it's a very open space.
What are you most excited about, not just with this mission, but with the Artemis program as a whole?
I think, to me, going to a place where we can base out of and go again and again is a really exciting opportunity. The missions that I have worked on, like the Mars rovers, for example, we go along a trajectory and we never come back to a place where we've been. And in the process of doing science, when we develop hypotheses and we want to test them, sometimes that can take a little while. Sometimes it takes a little while to think of something and then collect more evidence for it and think about it more and talk to people about it and then say, oh, you know what I could do is I could go test it this way. And so having a base is really going to afford us the opportunity to understand that area in much greater detail than we could with just going once and leaving. There are pluses and minuses to both approaches. Of course, we want to cover more ground. We want to see more diversity. We want to go to all the different places. That's also a great mode of exploration that I enjoy. But I think there's a special kind of joy in coming to a base and being able to go again and again.
Would you live there if you were given the opportunity?
100%.
Dr. Cohen, is there anything else you want to add about this mission?
Just that you can follow NASA's progress on nasa.gov/Artemis. Or at NASA on any of your social media platforms. Watch some of that live footage and be amazed by the moon.
Oh, man, I can't wait. Awesome. Thank you so much.
You're very welcome.
Off the Radar is a production of the National Weather Desk. Make sure you're following the show on Apple Podcasts, Spotify, or wherever you listen to podcasts. New episodes publish every Tuesday. Also, give us a follow on Instagram. You'll see clips from the show and some other great weather content. Just search Off the Radar Podcast. Thanks to Dr. Barbara Cohen for joining me today, and a huge thanks to all the media folks at NASA for organizing it. Thanks to the National Weather Desk and Sinclair Broadcast Group for their ongoing support of the podcast, and as always, to Brian Petrus for his help with today's episode. I'm meteorologist Emily Gracie. Make it a great day.